Welcome to solverfy.
We're asked to show that the first step of Sollin's algorithm produces a forest containing at least the ceiling of n over 2 edges when the input is an undirected graph with n vertices. So, recall from a previous exercise, we already know that the first step of Sollin's algorithm is going to produce a forest, right? What we want to prove is something a little bit stronger now, which is that the forest will contain at least the ceiling of n over 2 edges. So first of all, let G be a connected weighted undirected graph with n vertices. And first of all, construct a forest of n trees, where each tree has one vertex. This is just the first step of the algorithm. Now we have that every new tree that would be formed in the first step will contain at least 2 of the n trees. And I say at least 2 of the n trees because clearly we could be connecting more than 2 trees together in the first step. And thus there are going to be at most n over 2 new trees. Because each of the n trees has to be connected to a new tree. Now, this implies the number of trees were decreased by at least n minus n over 2. Which is equal to n over 2 trees and so we required at least n over 2 edges. This is because each edge reduces the number of trees by 1. So, since the number of edges is going to be an integer, we have that at least the integer that's closest to or greater than n over 2, so at least the ceiling of n over 2 edges were added. Again, since the number of edges is an integer,